Look up at the stars tonight. Go outside, pick a bright one, and just stare at it. You think you are looking at space. You are not. You are looking at time. You are looking at a ghost. The light hitting your eye right now left that star millions of years ago. If that star blew up yesterday, you would not know. The universe is keeping a secret from you, and it will keep that secret for 1,000,000 years. You see, we have this habit, this really arrogant human habit, of thinking the universe is just a bigger version of our backyard. If you want to go to the grocery store across town, you get in your car and you drive. If the store is further away, you just drive faster or drive longer. It is just an engineering problem. Add more fuel, build a better engine. We look at the stars, we think about alien civilizations, and we assume they're doing the exact same thing. We think they are sitting out there in some distant galaxy, building bigger engines, preparing to drive across the universe to say hello. We assume the silence of the night sky is just a temporary delay, but nature does not care about our engineering. Nature does not care about our intuition. Nature has rules, absolute, merciless rules. And today, we are going to talk about why those rules mean the universe is silent. Not because the aliens blew themselves up in some nuclear war, not because they are hiding from us, but because the literal laws of physics built an inescapable prison around every single star system. Physics killed the aliens, or at least it killed any chance of them ever knocking on our door. Before we break reality and rebuild it, make sure you are ready for this. This is not just physics. This is about understanding the actual machinery of the world you live in. Let us start with something simple. Hold your hand out in front of you. Now wave it back and forth. You feel the air against your skin, right? You feel the muscles moving. It feels instantaneous. Your brain says move, and the hand moves. But is it instant? No. Nothing is instant. The electrical signal from your brain had to travel down your arm. It takes a fraction of a second. We do not notice it because we are slow, sluggish creatures. But it takes time. Now, why does it take time? Why cannot things happen all at once? For a long time, we thought they did. We thought the universe was like a giant clock, tick-tock, everywhere at once. Sir Isaac Newton, a very smart man, he looked up at the moon and realized it was falling. He realized the same invisible pull that drops an apple to the dirt is holding the moon in its orbit. He called it gravity, and he thought gravity was instant. He thought if the sun suddenly vanished right this second, the earth would immediately fly off into the dark. Newton's math was beautiful. It worked perfectly. We used it to predict the tides, to launch rockets, to understand the dance of the planets. But there was a flaw, a tiny, nagging flaw. Mercury, the little planet closest to the sun, was not moving right. It wobbled just a tiny bit wrong. And then there were magnets. You take two magnets, you put them close, and they push each other apart. But how? There is nothing between them. How does the magnet in my left hand know the magnet in my right hand is there? Does it just know instantly? Is it magic? No. There is no magic in physics. If something pushes something else, a message has to be sent. And sending a message takes time. This brings us to the first merciless verdict of the universe, the speed limit. We call it the speed of light, but that is a terrible name. It is not about light at all. Light just happens to travel at that speed because it is a little jiggling blob of energy with no mass. The real name should be the speed of causality, the speed of cause and effect, the speed of reality happening. Imagine you have a long, rigid stick, a stick that reaches all the way from the earth to the moon. You push your end of the stick. Does the other end move at the exact same time? Our intuition screams yes, but it does not. It cannot. When you push your end, you are pushing atoms. Those atoms bump into the next atoms, and those bump into the next. It creates a wave of pressure traveling down the stick, and that wave cannot travel faster than the speed of causality. Even with a perfect stick, the other end will not move for over a second. Why? Because space is not just empty room. Space is a fabric. Imagine a vast, invisible mattress of springs filling the entire universe. When you move an electron, when you jiggle it, It shakes the spring next to it, which shakes the next spring. That jiggling travels outward. That is what we call an electromagnetic field. That is what light is, just jiggling springs. And the springs can only snap back and forth so fast. There is a physical limit to how fast the jiggle can pass from one point to the next. If an alien civilization, 1,000,000 light years away, decides to launch a ship to Earth, they cannot just accelerate endlessly. They hit the speed of causality. And this is where the universe builds its second wall, the energy wall. You have probably heard the phrase E equals mc squared. People throw it around a lot. But what does it actually mean? It means energy and mass are the same stuff, just in different forms, like ice and water. Now, think about what happens when you push a spaceship to make it go faster. You add energy at slow speeds, everyday speeds. That energy just turns into speed. But as you get closer to the ultimate speed limit, the universe starts doing something ridiculous. Because you cannot break the speed limit, nature has to do something with all that extra energy you are pumping into the engines. So it turns the energy into mass. The spaceship literally gets heavier. The faster you go, the heavier you get. If you want to push a ship to 99% the speed of light, the ship becomes incredibly massive. It takes more energy to push it. So you add more energy, and it gets even heavier. It is a vicious, inescapable cycle. To reach the actual speed of light, the ship would become infinitely heavy. It would require an infinite amount of energy to push it. You would need to burn every star in the entire universe just to power one ship, and it still would not be enough. The universe does not just give you a speeding ticket. It physically builds a wall of infinite mass to stop you. So the aliens cannot travel faster than light. But maybe they are patient, right? Maybe they build generation ships. Maybe they freeze themselves. This is where human intuition completely fails us again. We think time is a universal background, a stage where the play of the universe happens. We think now for me is the exact same as now for an alien on the other side of the galaxy, but the universe does not work like that. Time is not a clock ticking on the wall. Time is something that is woven into space itself. Space-time. Imagine space-time is a giant, long sausage. Everything that has ever happened and will ever happen is inside this sausage. Now, how do we understand the present moment? We slice the sausage. My slice of the sausage is my now. Your slice is your now. Because we are sitting still relative to each other, we are slicing the sausage at the exact same angle. Our nows match up. But motion changes the angle of the knife. If an alien millions of light years away gets in a spaceship and starts driving toward Earth, their motion tilts their knife. They are no longer slicing the sausage straight across. Their slice tilts forward into our future. Their present moment includes events on Earth that have not happened yet for us. If they turn around and drive away from Earth, their knife tilts the other way into our past. Their present moment might be the Earth when dinosaurs were walking around. It is like looking through two overlapping screens, like window screens. When you twist one screen just a tiny bit, you see these large, sweeping bands of dark and light across the whole window. We call them moire patterns. A tiny movement creates a massive shift in the pattern. That is what happens with space-time. A slow walking speed for an alien far away causes their slice of now to sweep across thousands of years of human history. Some people try to use this to say time travel is possible, or they invent paradoxes. They talk about dead cats in boxes being both alive and dead until you look at them. That is nonsense. Nature is not a trickster playing games with boxes and cats. Nature is just dealing with the probabilities of where things are and how they connect. And the connection here is simple. Yes, their slice of now tilts into our future or past, but it does not matter. It does not matter at all, because they can never send a message faster than the speed of causality to tell us about it. The universe allows them to experience a different slice of time, but it absolutely forbids them from interfering with ours before the light can travel the distance. The rules of causality remain unbroken, and that distance is the fourth merciless verdict. The space between the stuff. We say space is vast, but words do not do it justice. If the sun was the size of a grapefruit sitting in New York, The Earth would be a grain of sand a few dozen feet away. The nearest star, the next grapefruit, would be in California. And between New York and California, there is nothing. Just empty, freezing, silent void. We think we can just shine a very bright laser or send a very loud radio signal, and eventually someone will hear it. But nature has another rule, the inverse square law. When you drop a pebble in a pond, the ripples spread out in circles. As the circle gets bigger, the energy of the ripple is spread thinner and thinner. Light and radio waves do the same thing. They spread out in a sphere. By the time our brightest radio signals travel just a few light years, they are smeared out across billions of miles of space. They become so weak, so incredibly faint, that they blend in with the random static noise of the cosmos. The hum of the Big Bang, the crackle of distant hot gas, information decays. The universe is a perfect shredder of information over long distances. Even if a civilization screamed at the top of its technological lungs, by the time the sound reaches the next star system, it is just a whisper in a hurricane. And finally, we have the fifth verdict, the fragility of the stuff we are made of, the biology problem. We are sacks of water and carbon, held together by incredibly delicate chemical bonds. We exist because our little planet shields us with a magnetic field and a thick blanket of air. Space is not empty. It is full of radiation. It is full of little pieces of atoms, protons, and electrons, completely stripped of their normal state, jiggling and flying around at terrifying speeds. When you accelerate a ship to a significant fraction of the speed of light, you are not just moving fast. You are turning the universe in front of you into a particle accelerator. A single grain of sand sitting peacefully in space, if you hit it at 99% the speed of light, it does not just bounce off the windshield. The kinetic energy makes it hit with the force of a nuclear bomb. The very hydrogen atoms floating in the void become a lethal storm of radiation that will cook any biological material inside the ship. We are built for the slow, muddy surface of a planet. We are not built to survive the violent, high-energy friction of interstellar travel. When you put all of these pieces together, a terrifying and beautiful picture emerges. The universe is not a playground. It is a vast, expanding quarantine zone. The spaces between the stars are widening. Entire galaxies are being pushed away from us by the expansion of space itself, moving faster than the speed of light. Not because they are traveling through space, but because the space between us is stretching. Millions of galaxies have already crossed a horizon where their light will never, ever reach us again. They are gone forever. If you have never touched another human being, if you have never felt a hand in yours, you might think it is a tragedy. But think about the physics. When you touch someone, your atoms never actually touch their atoms. The electrons on the outside of your hand get close to the electrons on the outside of their hand, and they push each other away. They repel. That feeling of touch, that feeling of warmth, is just the electromagnetic force keeping you apart. You are always hovering a tiny fraction of a hair away from everything you have ever loved. You are fundamentally isolated by the forces of nature. The silence of the universe is the same isolation, just written on a cosmic scale. Are there aliens out there? Statistically, almost certainly. There are likely billions of worlds teeming with life, jiggling blobs of cells, building cities, looking up at their own night sky, wondering if anyone is out there. But they are trapped, just like we are trapped. Trapped by the speed of causality, trapped by the infinite wall of mass, trapped by the vast, spreading ocean of empty space. Physics did not murder extraterrestrial life. It simply built absolute walls around their homes. The universe gave us the gift of existence, but the price of that gift is isolation. And why does understanding this make life better? Why does it matter? Because when you strip away the illusions, when you stop pretending the universe is just an endless playground waiting for us to conquer it, you are left with a profound sense of humility. We are here. We are stuck on this rock, but look at what we can do. Sitting right here on this tiny grain of sand, looking through telescopes and scratching math on blackboards, we figured out the rules of the game. We figured out how the springs jiggle. We figured out the sausage of space-time. We mapped the prison walls. We might never shake hands with an alien. We might never hear their radio songs. but we share the exact same physics. The electrons in their bodies dance to the exact same rules as the electrons in yours. In that way, we are deeply, intimately connected to every single thing in the universe. We are the universe, trying to understand itself. And that is far more beautiful than any science fiction story we could ever invent.